There is no evidence that Nikola Tesla ever created or hid a $1 salt mix capable of powering a light bulb for 30 days. The real story is modern saltwater battery lamps and the myths we build around free energy. This script will treat the title as a hook to explore how saltwater lamps actually work, who really invented them, and why Tesla's name keeps getting attached to every new promise of miracle electricity. The night is thick and soundless in a tiny coastal community. Wind scrapes against corrugated metal roofs, and waves roll in heavy, invisible lines. In a one-room house, a child's hand tightens around the spine of a schoolbook as the only candle gutters and dies. For a few seconds there is nothing. No light, no color, just the weight of darkness and the quiet ticking of a clock that can't be seen. Then, in the corner of the room, someone lifts a small plastic container, pours in half a liter of seawater, closes a latch, and twists a simple switch. A white glow blooms across the walls. The room returns. The child keeps reading. A lamp powered not by gasoline, not by a lithium battery, not by a noisy generator, but by salt water. Something that looks like a trick, a loophole in the rules of physics, a glimpse of a secret technology the world was never meant to have. Online, the claim spreads with infectious speed. This $1 salt mix powers a light bulb for 30 days. Why did Tesla hide this? The question is designed like a lockpick, engineered to pry open our oldest suspicions about energy, power, and the people who control both. This is the story behind that claim. It is a story of real engineering and quiet innovation, of misunderstandings and exaggerations, of the human hunger for free energy, and of how the name Tesla became shorthand for everything we wish were true. It is not a conspiracy thriller, although conspiracies will appear. It is not a piece of clickbait, although it begins deliberately with a piece of clickbait. It is an invitation to step behind the thumbnail image and see what actually happens when salt, water, metal, and human imagination meet. The idea of turning salt water into light feels like something out of science fiction, but the underlying principle is almost disarmingly simple. Inside a saltwater lamp, there are two different metals, electrodes, submerged in a salty solution. One acts as the anode, the other as the cathode. When salt dissolves in water, it splits into charged particles, ions that can move freely. When the metals are connected by a wire and the circuit closes, chemical reactions begin at their surfaces. One metal gives up electrons more readily than the other. Those electrons flow through the circuit, and that flow is what we call electric current. In other words, the salt mix is not magical fuel. It is an electrolyte, a medium that allows a controlled, slow corrosion of metal to be harvested as electricity. The water does not burn. The salt does not burn. The lamp is not tapping into a hidden ocean of zero-point energy or a secret formula discovered in a lost notebook. It is a battery, ingenious, practical, and finite. For engineers like Lipa, Aisa, Mijena in the Philippines, this finiteness is not a disappointment. It is the whole point. In regions where grid electricity is unreliable or absent, people often rely on kerosene lamps that are smoky, hazardous, and expensive to keep fueled. Mijena and her colleagues developed a portable saltwater lamp, capable of producing light for around 8 hours on just a glass of seawater, with the internal metal components lasting months under typical use. Not forever. Not a miracle. Just long enough to matter. In Colombia, a company called Mijena, working with Wunderman Thompson, designed WaterLight, a rugged lamp that can convert half a liter of seawater into up to 45 days of intermittent light, depending on how often it is used. For coastal communities like the Wayuu, where the ocean is close but power lines are far away, this technology can mean the difference between a night spent in darkness and a night spent studying, weaving, cooking, or working. The lamp's internal magnesium copper cell slowly sacrifices its metal plates over time. Each refill of salt water triggers more corrosion, more electrons, more light. These devices are sometimes described breathlessly: just add seawater and get 45 days of free light. But that sentence leaves out the cost of the materials, the fact that the useful life of the internal cell is measured in thousands of hours, not infinity, and the reality that the metal plates eventually need to be replaced. It also leaves out something deeper. Nothing about these lamps violates known physics. They are not loopholes in the laws of thermodynamics. They are illustrations of those laws. Yet when a short, vertical video shows a person pouring salty water into a jar, attaching a simple LED, and making a triumphant promise, "This will save you money on your electricity bill for a month," the comments fill with familiar refrains. This is what Tesla tried to give us. They hid this from us for 100 years. Imagine if everyone had this, the power companies would go bankrupt. Why does the name Tesla keep appearing here? To answer that, the documentary has to change rooms. The scene dissolves from the dim light of a coastal shack to the crackling violet arcs of a laboratory in the late 19th century. In the center stands Nikola Tesla, tall, austere, face lit intermittently by the violent flash of electrical discharges leaping from a massive coil. Tesla was, by any measure, a visionary. He championed alternating current when many of his contemporaries favored direct current, designed motors that still form the basis of modern electrical machinery, and experimented with wireless transmission of power and radio waves. He spoke in sweeping, often poetic language about harnessing the forces of nature, tapping into the energy of the earth and the atmosphere. To a public grappling with the sudden, uncanny arrival of electric light, he seemed less like an engineer and more like a magician. Over time, this aura hardened into legend. Stories grew around his work, that he had built machines capable of drawing limitless energy from the ether, that he had developed devices which could supply free electricity to the entire world, that his laboratories were the birthplace of technology suppressed by oil barons, bankers, and governments fearful of losing control. The truth is stranger and in some ways sadder. Tesla did dream of transmitting electrical power wirelessly, and he sank enormous effort and money into building the Wardenclyffe Tower on Long Island as a possible platform for this dream. But the tower's power source was conventional, a coal-fired generator. The energy he hoped to transmit would still have to be generated by burning fuel. The idea that Wardenclyffe was secretly pulling power out of the sky, the earth, or the fabric of space itself is a modern myth layered on top of historical fact. Tesla filed many patents. None of them describe a simple saltwater battery capable of keeping a household bulb lit for a month on $1's worth of ingredients. None of them describe a working device that could break the arithmetic of energy itself. He did not, as far as the historical record shows, hide such a device. He did not build it. So why connect him to a jar of salty water and a strip of magnesium? Because the story of a modest, incremental improvement in battery chemistry does not spread the way the story of a silenced genius does. Because in an age of algorithm-driven attention, the phrase, "Why did Tesla hide this?" is not a question, it is bait. The $1 salt mix that supposedly powers a light bulb for 30 days is stripped of its drama, a version of a galvanic cell, a direct descendant of the earliest batteries humans ever built. In a battery, chemical potential energy is converted into electrical energy through redox reactions. One material oxidizes, loses electrons, while another is reduced, gains them. The salt water, rich in ions, allows these charged particles to move, completing the circuit. The cost is not paid in dollars magically generated, but in atoms quietly rearranged. In practical saltwater lamps, the choice of metals is a balance between cost, availability, and performance. Magnesium is often used as the sacrificial anode because it corrodes readily in the presence of salt water, releasing electrons that can be harnessed. Copper or other metals may serve as the cathode. The voltage produced by a single cell is relatively low. To power a bright LED, multiple cells can be arranged in series, stacking their voltages like children standing on each other's shoulders to reach a high shelf. Claims of 30 days, or 45 days of light hinge on the definition of day. If a lamp is used for a few hours each night, the total operational time can indeed stretch into weeks before the metal plates need to be replaced, especially if the current draw is modest. But this is not the same as a single cup of salt water burning continuously for a month. Instead, the water is periodically refreshed, the chemical reactions pause and resume, and the internal components gradually wear out. Here is where the narrative tilts dangerously. When a video compresses this slow, consumptive process into the phrase $1 mix, it suggests that the only cost is the salt and water, $1's worth of ingredients swapped for a month of continuous energy. The hidden cost, the magnesium, the manufacturing of the cell, the plastic housing, the logistics of distribution, is invisible. For a viewer scrolling past, the impression is irresistible. Here is a method to outwit your utility company with kitchen-level materials. For communities without access to a stable grid, the calculus is different. A family that spends a significant portion of its limited income on kerosene can significantly improve its financial and physical safety by switching to a saltwater lamp, even if replacement plates cost money and must be imported. A lamp that uses the ocean, a resource literally at their doorstep, as part of its chemistry can feel like a kind of magic, even when the science is well understood. But when this same technology is presented to viewers in countries with robust electrical infrastructure, the framing changes. The saltwater lamp is no longer a lifeline, it is a supposed hack, a disruptive secret, an almost illicit shortcut around the system. That is where the myth of suppression surfaces. If this works, the logic goes, then they must not want us to know. The "they" is left unnamed, but the implication is always the same: corporations, governments, and somewhere in the shadows the ghost of Tesla. In reality, devices such as WaterLight and other saltwater lamps are not hidden. They are marketed openly, win design awards, and are covered by mainstream media outlets. Engineers publish their work, nonprofits raise money to distribute these lamps, and companies tout their impact on off-grid communities. The bottleneck is not secrecy. It is cost, supply chains, local politics, and the hard, slow work of deployment in places where infrastructure is fragile. The documentary now returns to the child under the saltwater lamp. The light on their face is not free in the cosmic sense. It is the end of a chain that begins in mines where magnesium is extracted, in factories where components are stamped and assembled, in offices where engineers tested prototypes late into the night. Yet for that child, tonight the lamp feels like freedom. It means homework can be finished, stories can be read, fears can be kept at bay. It means the dark is no longer absolute. Tesla's name was never needed to make this moment happen. The principles behind the lamp could have been understood in his time, but the specific designs used today are the result of many people's work, not the unearthing of a hidden notebook. The myth that he hid such solutions distracts from the very real, very human struggle to fund them, manufacture them, and place them where they are most needed. Why, then, do we cling to the idea of hidden energy? Why does the phrase, "they don't want you to know this," still pull us in? Part of the answer lies in how complex, opaque, and unequal our current energy systems feel. Power plants are distant, electric bills can be confusing, and the environmental cost of electricity is often invisible until disaster strikes. Against this backdrop, a jar of salt water and a strip of metal are comforting. They suggest that the rules are simpler than we were told, that with the right formula, we could step outside the grid entirely. There is a danger in this comfort. When we overstate what a saltwater lamp can do, we risk two kinds of disappointment. In one, people try to replicate viral videos at home, only to discover that the current is weak, the light dim, the metals quickly exhausted. The claim of saving 100 reais on your electricity bill dissolves under the reality of physics and cost. In the other, communities who might benefit the most from these technologies are overlooked because the conversation has moved on to the next supposed miracle, the next promise of a machine that can run forever on water, magnets, or ambiguous diagrams. And yet, there is also a kind of beauty in the persistence of the myth. It speaks to a deep, recurring hope, that the world is more generous than we think, that somewhere in the interplay of elements and fields there is a way to live with light and warmth without damage or debt. Tesla himself felt something like this. An almost spiritual belief that the universe seethes with energy waiting to be tapped. He was wrong about the specifics of free energy as it is popularly imagined, but he was not wrong to see energy as abundant. The sun alone delivers more power to Earth in an hour than humanity uses in a year. Our challenge lies in collecting and distributing it wisely. The $1 salt mix of the title is not the key to that future, but it is a small, tangible example of how clever design can reshape what is possible at the margins of the grid. It shows that you do not need to wait for a breakthrough in fusion or the revelation of a suppressed blueprint to improve lives. You can take known chemistry, adapt it to local realities, and create devices that turn dark nights into usable hours. If there is a secret here, it is not the composition of the solution in the jar. It is the uncomfortable, unglamorous truth that energy transitions are made not only of spectacular inventions, but of thousands of small, patient improvements. A lamp that runs on seawater in a fishing village. A solar panel on a rooftop. A more efficient motor in a factory. None of these makes for as thrilling a headline as Tesla's hidden formula, but together they are the only real path we have. The documentary closes not with an accusation, but with a reframing of the title's question. Why did Tesla hide this? He didn't. The more pressing question is, why do we keep hiding from the reality that there is no single, perfect, cheap, infinite source of power that will erase our responsibilities? The lamps of salt and water are honest in a way myths are not. They shine as long as their materials allow, then fade, reminding us that every lumen has a cost somewhere, paid in metal, in labor, in time. Understanding that cost does not make the light less miraculous. It makes it more so. In a world where so much of our electricity is abstract, these humble devices reconnect us to the chemistry that underlies everything from a phone battery to a storm cloud. They invite us not to believe in hidden geniuses and lost recipes, but to appreciate the people, known and named, who are working in the open to bring light to places where darkness once seemed permanent. In the end, the real power of the $1 salt mix is not that it cheats physics, but that it challenges our imagination. It asks whether we can be satisfied with technologies that are limited yet transformative, imperfect yet life-saving, and whether we can learn to value the hard, visible work of progress over the seductive idea that somewhere, someone solved everything a century ago and simply chose not to tell us.